string and how do I store it in the RAM? I need a way to convert any string into some binary value. No, that's not conditionals. Okay, so you are saying A is equal to 1, B is equal to 2, but 2 also I can't store in RAM. So what can I do? I have to come up with some equivalent in zeros and ones. Okay, yeah, so you're getting close to the answer. So what I should do is I should take every character, I should take every character and come up with a numeric representation for it. Okay, take every character of the alphabet, take every character that we use in English and convert it into a number, have a numeric representation. Now, once I have a number, I know how to store it, isn't it? Suppose I have a number, then I know how to store it in the RAM. Because yesterday we learned how to take a number and store it in the RAM. So my question is, I want to take this character called J of John and somehow convert it to a number. So how do we do that? So this is where we have something called ASCII. How many of you have heard about ASCII tables? ASCII. Have you heard about this? ASCII. 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 Some of you probably have heard about it. You probably don't know what it is, but just search the term called ASCII. ASCII. That's what ASCII is. ASCII table. ASCII art, yeah. So ASCII tables. You have this thing called ASCII tables. All right. So when you search for ASCII tables, I mean, you can open any link. You'll come across this table where for every character of English, there is a corresponding number mentioned. So for every character of English, there is a number mentioned. So A is 65. All right. And the character B is 66. The character C is 67. So if I take the word called John, can you tell me what is the equivalent in ASCII? What would be the corresponding numbers? Can you tell me? So here is the ASCII table. I'll share it in the chat window. So tell me what is the corresponding numbers. I'm sharing it in Etherpad, okay? So here is the ASCII table. So what is the corresponding thing for John? The word John. What is the corresponding thing in ASCII? Okay, so let's see if that is right. 74, 79, 104, 109. So 74 is J, correct? 79. Now 79 is a capital O, but I want the string capital J and then all the others are small letters. So then what? So it is the small letter O, which is 111. H is a 104. Yes. And then finally the N is a 110. All right. So the capital J is 74, correct? And then we have small o, 111, H is 104, and the N is 110. So what is happening? Let me pictorially describe that. We are essentially taking the characters John, and we are looking for a mapping for every character. All right. So we create some sort of a, first I'm going to just write the numbers, but just keep in mind, number is converted to the corresponding binary. So now I have these 4 digits, 4 numbers. So J first. J is what? It was 74. All right. And then comes the character for O, which is 111. 111. and then comes the H, which is 104, and then comes the N, which is 110. Is that fine? So this is 74, 111, all this. So what happens when you store something in your system or when you store something in the RAM? It takes the characters, but remember, the computer doesn't understand all these characters. So what is it doing? It's taking each character and we are converting it into some binary representation. So when I convert it to a number, remember number means I can convert to binary. So that's not a problem. So I convert it to binary and I store it in the RAM. All right. So you can imagine that when I say name equal to John, what is happening? What is happening internally? So somewhere in the RAM, it is creating a number, a sequence of numbers. Okay, so somewhere in the memory, it's creating a sequence of numbers. Now again, I'm going to put the number itself for now, but I want you to understand these are all going to be converted to binary. And then it's going to be referred to as the variable name called name. So when I say give me the name, it's going to give me all these values. Now, usually to say this is done, we normally store a 0 in the end to indicate that, yeah, we are done. This is the last character. So it's called the end of string marker. So we have some way of storing it, but don't worry about it. So we are kind of storing all these values. So we're saying name equal to John. Now, do you understand how we take some string of our English words and store it in the RAM? We store it in the form of these strings. All right. Okay. Now, this is all fine for English, but I know that there are many people in this call for whom English is not probably your first language. How do we convert it to 0 and 1? That's what we learned yesterday, isn't it? How do I take 74 and convert it to zeros and ones? So you keep dividing it by 0, sorry, by 2, and you take the stream of zeros and ones, the remainders. Does that make sense? Yeah, so the same technique we used yesterday. We can take any number, we know what it takes to convert it to zeros and ones, isn't it? So that's not a big deal. But yeah, so for many of us, English is not. Um, you want me to repeat that? I'll show you with an example. So let's say we take the number called 74. We take the number 74. How do I convert this to binary? 1 minute. So we take the number 74, divide it by 2. What is it? 2 3s are 6, 2 7, 14. Remainder 0. Next, divide by 2 again. 2 1, 2 8. Remainder 1. Divide by 2, 2 9. Remainder 0. Divide by 2, 4 1. Divide by 2 again, 2 0. Divide by 2 again, 1 0. So this sequence of zeros and ones, 1 0 0 1 0 1 0, is the binary representation of the decimal 74. Is that fine? Yeah, so that's the understanding. So now in the RAM, if you see, you would have seen this sequence of zeros and ones. And by the way, again, this is converted to 8 bits containers. Remember the concept of container. So we convert it to at least 8 bits. So here, how many bits do we have? So you see we have 7 bits. So I can pad it with 1 0. So that becomes 8 bits. So now this is what is actually stored in the RAM. All right. Okay, but now, like I said, most of us have some other language probably as our first language. We're not talking, we speak English, but that's not the only language we speak. So maybe some of you know maybe French, or so there's some other languages you may be knowing, Russian, or Chinese Mandarin, or one of the Indian languages. Now those things, they are not represented in ASCII. Yes, you can go to the ASCII table. You don't find all those characters here. So then how do I store it? How do I take a non-English character and store it in the RAM? So now I need a mapping which is not just for these English characters. I need a mapping for all the characters of all the languages which have a script. Yes, I need a mapping for all the characters of all the languages that has a script. So we have to convert the non-English characters not to English, but we need a mapping. Just like how we have mapped the English characters to a number, we need to map the non-English characters to a number. We need a mapping for all of them. How do we do that? How many of you have heard about this thing called Unicode? Unicode. Heard about it? Unicode? Heard about? Yeah. So you probably, if you're setting your keyboard sometimes for non-English characters, you probably do some, keyboard settings, right? And you probably have heard about this thing called UTF-8. Have you heard about UTF-8? Not yet? Okay, you'll probably come across this. So UTF-8 is just a much larger table. It's a much larger table for our characters. So we have a UTF-8 table. Now this is very, very large. It's a UTF-8 table is a much, much larger table, which probably goes, you can have a mapping for most of the characters, not just for the English characters. Can someone share a non-English character with me? I mean, because I'll just make it a little more real time, right? So you can probably share one of the non-English characters through the chat. Okay, so here is a non-English character. So let me take that, and I just say this character, all right? And I say this character, what is its UTF-8? What is its UTF-8? And you can see that somebody has given me this character and its corresponding decimal number somewhere, all right? So they give this UTF-8 encoding, and this is the HTML entity for it. And there is a corresponding number which represents this particular character, okay? So you can ask, how do I convert this UTF-8 value into a number? And there is something called a UTF-8 encoding and all that. But basically, in simple terms, what you're doing is you're taking these characters and you're coming up with a number to represent that character. All right, you're using a number to represent that character. So you can probably say decimal value for this. Okay. So you can probably find some decimal mapping. So in UTF-8 you normally get that, and so you can actually get the decimal mapping for these characters. So most of these characters have some kind of a decimal mapping. I don't know if it's there for the character that you shared, but you can actually go and find out. Okay. Yeah, so there it is. So this is your decimal number mapping for this character pi. So it's 1055. All right. I don't know what it's called, but yeah, that's the mapping. And you can get this for pretty much every character. Anything else you want to share? Okay, I'll take the one that you have shared here. I don't know if it's there in this page, but let's try it in. So there it is. Okay. So there is a number 327 to represent that. So that's the equivalent. All right. So when you take these characters, even these characters you can store in the RAM. And so what happens when you store this in the RAM? They get converted into a corresponding binary form. And that's what we call as the UTF-8 encoding. Don't worry too much about it. Just keep in mind that every single character of every single language which is popular, which has a script, there is a corresponding decimal to represent it. And there's a way for us to store it in the RAM. Okay. So that's the thing you should understand. So we are now taking this. So we are taking these non-English characters and we are storing it in the form of a decimal number. And that is what is actually getting stored in the RAM as some kind of a binary representation. Now, the interesting thing here is, you know, these emoji symbols that we use, the emoji symbols that we use, even these emoji symbols actually have, they are considered characters. They are also considered as characters. So even they have, they're part of strings. That's why we consider them as part of strings. So even the emoji characters are considered part of the string. So for example, I can say smiling face emoji. All right. And you can see if I take this character, if I take this character, I'll copy this. And if I say, what is the UTF-8 for this? You'll see that even these emoji characters have a corresponding number. All right. So there's a way to represent these emoji characters also as a string, as a character. So this emoji character for smiling face is no different from a character like A. Both are just characters. All right. So I can use this character, although it looks like an image, it is not, it's just a character. And so I can use this when I'm actually creating a string in a programming language. Shall we try that? So I can actually go to my terminal and you can see here, I can use something like description and I can just put this character here. You see that? I can use this just like a character. So because all these emoji characters also have a corresponding binary representation and they are all considered like characters of a language. Okay. So practically everything we see on a screen has a string. It has a character representation. Yes. All right. Okay. We can store in the RAM not only ones and zeros, but 47585. See, the 47585 that you see is what is converted to numbers. It's only the second part. Okay. It's only the 47585 that is being used. And that is the one which is actually being stored in the RAM. It's a 47,585. That number is somehow being stored in the RAM as a binary representation. Okay. So that's what you should understand. So the HTML entity needs to be, it is a decimal. Okay. So what you're seeing here, so I can actually show you with a demo. I don't know if this will confuse you, but I just want you to try this out. Suppose I create a file. All right. I'm just creating a file. So in the file, I will put one of these characters. So let me just pick one of the characters that you shared. Okay. So I'll pick the character for the pi symbol and I'm saving this file. Okay. Save the file. Now don't worry about what I'm doing here. I'm just saving the file. This is the file which has this character. Now, how is it actually internally stored in the file system? It is being stored as this character called D0BF0A. Okay, so internally it's being stored as D0BF0A, and that is the decimal or the binary representation. Hexadecimal means it's a binary, but it's combined together. It's stored in a certain form. If you now take this And if you look at what that representation is, you will see it is the same as what you are seeing in this uh, document. So if you see in the browser for the character for this, what is it? It is D0BF. So it is D0BF. So this D0BF is the UTF-8 encoding for this character. And this D0BF is just a hexadecimal value, which is just a, it's a binary only. When you say hexadecimal, there is a way to, talk about that in terms of zeros and ones. I'll not go too technical here, but just keep in mind all of these are essentially ways to represent numbers. And so every character, there is a corresponding binary. That's what is being stored. So it's not the ampersand hash. That's just a way we represent it in HTML. I want you to see these numbers, the UTF-8 encoding, D0BF. Now, what is D0BF in hexadecimal? There is a corresponding binary representation. You can use a calculator. Um, I'm opening a calculator now and just type in hexadecimal D0BF and D0BF and then convert it to binary. So this is the binary representation of D0BF. And this is what is stored in the RAM to represent that pi symbol. Is, is that clear? This is what is actually stored in the RAM. So similarly, if I take the other one, let's say I'm taking the yen symbol. I don't know what it's called, but I'm just doing the same demo now with the other character. So just observe what happens. So suppose I store this in the RAM, in a file. I'm storing this in the file. So in the file hello, I'm storing this character yen. If I ask how is it actually stored on disk, it's telling me it's stored as C588. That's how it is actually stored on the disk. And what is the C588? Open a calculator, look at how that character C588 is stored. So go to C588 and go to the corresponding binary. This is the binary representation of that character. And that's the same as what you will probably see in that table. So if you go to this table, you can see the representation is hexadecimal C5 hexadecimal 88. So that's the way that number is being stored. All right. So don't worry much about the internals of it. Here is all I want you to understand. Every English character and every non-English character and all these emojis have a way to represent the corresponding character. Where can I get this? I'll share this link with you as an example for UTF-8. UTF-8, and just type the character here in the top. For example, the Indian rupee symbol is typed using 20B9. This is the rupee symbol. And you can see that the rupee symbol is represented in UTF-8 as E282B9. So it's made up of these three characters, three numbers, sorry. And so there's a corresponding binary representation for it. Okay, so that's the way you can do it. So type any Unicode character here and search, and you will find that there is a corresponding UTF-8 encoding, and that UTF-8 is the form in which that data is actually being stored in the RAM or being stored in your file. When you store a file, it's being stored with this particular format. That's how the representation of that character is in binary. You're following this? Any questions? Don't need to worry too much about the representation itself. All I want you to know is that all characters have a binary representation. Okay, so yeah, so we learned about what it takes to represent strings as binary. And so what we are doing now is we are taking various strings and we are converting that into some binary format, and we are storing it in the memory. Okay, is it the same way that colors are represented? Good question. How are colors represented? Now, every color in the world that we see is made up of three basic colors. Do you know what they are? What are the three basic colors that we use? Every color that we see is made up of three basic colors. Yeah, so we call it as R, G, and B, red, green, and blue. So every color that we see is made up of these three colors. So if I want to represent any color, I can basically take, I'm picking a color picker here just for an example. So I want to create a certain color. So you can basically see that I can move this here, okay? And there's a certain color that I have here. So this is the color, okay? Now what is this color's representation? How do I represent this? So you see it says it is a number 229, 177, and 97. So it's 229 of red, 177 of green, and 97 of blue. So here each of these numbers runs from 0 to 255. 0 means this component doesn't exist. There is no red at all. If this is 0, that means there is no red at all. And similarly, if it is 255, it means full red. All right. And then comes the green, again goes from 0 to 255. And then 97, again it can run from 0 to 255. So if I have a complete red, like a 255 of red, but I don't have anything of green and blue, then the net color is red. So what is the representation of colors? How do I represent colors? So to represent a color, I need three numbers. I need three numbers. And each number runs from 0 to 255. Now, if you see why 255, can you tell me why it is 255? What is 255 in binary? You will see, it's interestingly, the number 255 can be fit into one, combination of 8 bits. So if I go with the number 255, this is a special number. You see that in binary, it is a total of 8 digits of 1111. 1111, 1111. So totally you have within one 8-bit container, I can store a maximum number of 255. So how do I represent colors? I use three numbers, each of which can run from 0 to 255. Now using a combination of that, I can represent various colors, okay, just by combining various values of this, okay. So yeah, you can try with different combinations and see which colors you get. And you can pretty much create any color in the world using just these three numbers. Okay, so when you're representing colors, so for example, imagine you're showing an image of a person. How is the image represented? Can you tell me? What is the image made up of? What is the image of a person made up of? Or any photo, when you see a photo, what is it made up of? So we have a concept of pixels, all right? So, and each pixel is one particular point in the screen. Each pixel is represented using one RGB value. So there is a number from 0 to 255, three such numbers representing one pixel. All right. So what you are getting in the screen is a bunch of RGB values for each pixel. And so when all this is being sent to the monitor, it is just representing each color, and that's what you're seeing as a photo. That's basically how images work. That is how colors are represented. So to represent a photo, you have to take the value of each pixel, and for each pixel you have to ask what is its R value, what is its G value, what is its B value. So you have to basically ask these three numbers. And so when you combine those, you get the value of one pixel. And so you slowly keep asking the values of all the pixels. Okay. So is this clear? We'll try some of these in the future when we learn about arrays and ways to combine multiple values together. We will learn about this. So yeah, we learned about a new data type today, the string data type. And we learned about how we can represent various strings of various languages. So it can be English, it can be a lot of the non-English characters, or it might be even things like emojis. All of these are essentially represented using characters, and the characters have a corresponding binary representation. So for English characters, we have a ASCII table to get the corresponding binary. For the non-English characters, we have something called a UTF-8 representation, which can give me the equivalent binary. Any questions so far? Are you following this? Yes? Any questions? Okay, great. So with this knowledge now, I had asked you folks to find out what other data types exist. Did you find out? Did any of you find out what are the other data types in Python? Yes. What else did you come across? Okay. Set, list, boolean, yeah, boolean, int, long. Okay, long was there in Python 2. It is not there in Python 3. Okay, in Python 3 we only have int. But if the number was beyond a certain size, we used to have long in Python 2. But right now we only have int. A tuple, okay, a tuple, a dictionary, correct? Yes, a dictionary is also a data type. So now, if you look at all the data types in a programming language, you will typically see that there are two types of data types. Okay, I'll just tell you what they are. So just a moment. Just one moment. That's my wife in the background. So she's singing. She's actually taking a class. So so yeah, that's my wife in the background. So she's also taking a class. So so we're sharing a room. So she's taking another class in the other side. She's not able to hear me because she's put on earphones and she's practicing with her teacher. All right. Yeah. So when it comes to data types, there are broadly two categories of data types. Okay. So we have we have something called primitive data types, and we have something called composite data types. I'll pass on your compliments to her. So we have two data types, primitive and composite. Um, so what are primitive data types and what are composite data types? Primitives are things that we cannot break any further. So when we store something in the RAM, we store it as a certain unit, and then we take that whole unit back. So we always work with a complete unit. So for example, when we talk about a number is a number, right? When we say we are storing this number called 10 in the RAM, so it's a number 10. There's nothing like a part of 10. Can you give me, like a can you somehow split that 10 into something smaller? There is no such thing. When we talk about a certain name of a person, we can probably say, okay, the name is stored as a whole. We can take the whole name back. Okay. When we talk about booleans, for example, we can store an entire boolean in memory, and we can get the whole boolean back. Okay. So things like numbers, things like strings, things like booleans are essentially primitive data types. So we can store the whole thing in the RAM, and we can take the whole thing back. But there's no way to kind of talk about a portion of it. So that's what we refer to as primitive data types. All right. And on the other hand, we have something called composite data types. What does the word compose mean? What do we mean by compose? What does the word compose mean? Yeah. So composing something probably means we are somehow, yeah, you're kind of grouping or bringing things together. Does that make sense? Like we're bringing, yeah, to piece together. That's a good example. So you're piecing things together. You're kind of bringing different pieces of information together into one container. So the best analogy I can give you is imagine if I say I want you to carry three different things, right? So now what will you do? Let's say you package the first item into a box. That's your data type. So you say, okay, I'll put this in one box. And then the second item, you'll put that in one box. You'll take the third item, you'll put it in a box. And now you'll take all these three boxes and put it in a bigger box. All right. I don't know if that is how e-commerce companies deliver packages to you. So suppose you buy three different things. So they might put each item in a box of its own, and then they put all of them in one big box, and they kind of ship that one big box to you, right? That big box is the composite type, and the smaller boxes are the primitive types. All right. Now, what is the implication of this in programming? Can you tell me among the various data types that you spoke about, can you tell me what are some of the composite data types? Among the various data types that you guys spoke about, can you tell me what are the composite data types? What are some of the examples of composite data types? Yes, arrays is an example of composite data types. Anything else? In Python, if you talk about Python, what are some of the examples of composite data types? Sequence, yeah, I mean, there are two types of composite data types. We'll talk about that. We call it as sequential data types and non-sequential data types. But here in this particular example, can you tell me what are some of the composite data types? I mean, you have mentioned it in the chat window. If you go up and start looking at the various things that you folks mentioned, all those things have been mentioned. You have actually listed all of them. Something that helps me to group pieces together. Int is not that, isn't it? Int is one value. If I say this is a number 10, that's it. But there's no way to split the 10 into something more smaller. So int is already the smallest. Yeah, so set is an example. It's a set of something, isn't it? We say this is a set of numbers. List. List is what? List is a list of something. It is a tuple of something else. It's a table. Table, there is no thing called table as such in Python, but yeah, you can think of a table to be made up of many rows and columns. So you can think of that as a data type, okay? And a map of something, array of something. So you see all of these, what you listed, set, list, tuple, somebody mentioned dictionaries. These are all examples of a combination of many smaller entities. It's a combination of something else. A float, um, yes, you could say that I can split a float into maybe the thing before the decimal and the thing after the decimal. You're right. But generally speaking, in a language, we don't talk about a float being decomposable. A float is a single entity. Okay. You can't take a portion of the float and store it as a separate entity. So uh, floats are considered as primitive data types. Okay, but yeah, I mean, you might think of float as something we can split into two parts, but here we can't. We are talking about float as a whole entity. All right. So floats, any numbers, like int, long, float, double, boolean, string, these are all considered as primitive data types, while things like lists, tuples, set, dictionaries, these are examples of composite data types. Now, can you tell me a real life example of a composite data type? Like, for example, in natural lingo, when we are talking to somebody, where would we use this concept of composite data types? Can you tell me in real life? Now, for example, when we talk about primitive data types, I gave you examples. I said, okay, what's your name? You say, my name is John. So now that's the name John is one data type. It's one value. You're saying this is one string. What's your age? My age is 20. That's one value. Now, similarly, when do you think we use this concept of multiple values as a single entity. What's a good example for that? Can you give me some example? A list, yeah. Can you give me an example of how we use this list? Yeah, exactly. So the list of attendees in this meeting, there are many people. All right, there are many people in this call. Now, if I ask, give me, just look at the way I'm talking it. Give me a list of all the attendees. Give me a list of all the attendees. So how many lists do I have? Only one. Give me a list of all the attendees. Now, attendees is what? I may need their names. So the list of all the attendees of this meeting is a list of what? What is each attendee? What is, how do you represent a person's name? It is in the form of which data type? What is the data type for one name? Yeah, it's a string, correct. It's a string, it's not int. The attendee is a name, so it is a string. So now I'm saying, give me a list of all the attendees of this call. So what will that be? A list, one list. So that list is a composite data type of all the attendees of this call. So each of them is a string. So it becomes a list of strings. All right. So how do I do that in Python? I just want to leave you with this today. We will discuss more about this in tomorrow's session. So I'll just leave you with this thought of how we can represent lists in Python. So we can say something like square brackets. Now this is a way to represent a list of values. We are representing it as a list. A list is represented using square brackets, and the individual items should be separated with a comma. So if I want to create a list of all the attendees, I can say there is a person Aksa, there is a person Billy, there is a person, what is it? Yeah, and so on, right? There is, who was the other one? So Michelle. I'm talking about the people who are interacting. There are many more, so please don't think this is representative of this call. But yeah, these are all the people, right? So this is a list of what? This is a list of strings. It's a list of strings. All right. So similarly, I'll represent all the people in this call. So there are 22 people in this call. So this list of 22 strings forms the list of all the attendees of this call. All right. Please share the calculator link. There is actually, the calculator is an application in my laptop. Unfortunately, I don't have it online. I don't know if there is some scientific calculator which I can look for online. If I can, then I'll probably share it with you. Okay, but yeah, this the one that I'm using is, or maybe I can search for programming calculator. Yeah, maybe you can look at this calculator and see if, yeah, just look for something called a programming calculator. You might find something, or you might even find this in desktop applications. Okay, so just, yeah, has a programmer mode. I think there should be one. So what chapter are we in Codeverse? We have something called data types. We have something about data types. So there are two things there. One is, there is a concept about data types in basics of programming, and then there is something called data types in Python, and there is something called collections in Python. So you can start looking at all those. That's the one. Yeah, the one that you have shared, text to binary converter. There's also a decimal to binary converter. You could actually look at that. Yeah, this is a good example. I'll add that in the Etherpad. Thank you for sharing. The calculator to convert decimal to binary, etc. You can use this. Great. All right. We've run out of time. I know these sessions look very short because, by the time I explain the concept, we are almost done. So yeah, in the Codeverse, please go through the lessons on basics of programming, look at the lessons on data types. There is basic data types in Python, there is basics of programming in Python, and there is one on collections in Python. So what I've just started off with are collections in Python. So I'll be going a little back and forth initially. So hopefully by the end of tomorrow's session, I should give you at least some basic ideas of collections. Okay, great. So we are done with today's session. Please continue with the lessons and we'll meet tomorrow at the same time. Okay, thank you. Bye-bye.